All right, let's just get right into it. When we talk about HTML5, you gotta understand this wasn't just another version number. This was a fundamental shift. It was the moment the web stopped being just a collection of documents and started becoming a full-blown application platform, one that could do things we used to think were only possible with software you install on your computer.
And you can see that shift right in the code. I mean, look at this. Before HTML5, we built everything out of these generic div boxes. It was a total mess, like trying to build a house where every single part, from the door to the roof, is just labeled plank. It kind of worked, but it was completely meaningless to a browser or a screen reader. HTML5 gave us a proper vocabulary. It replaced that soup of divs with descriptive tags like header, nav, and article, so the browser finally understands the actual structure of the page.
So the very first step in this whole evolution was basically a massive cleanup. The goal was to force a clean separation between a page's structure, what the content is, and its visual style, or how it looks. To pull that off, a whole bunch of old tags just had to go. Things like font and center ripped right out. And why? Because their only job was visual. The new rule was dead simple. HTML defines what something is, a heading, a paragraph, an article. CSS handles how it looks, the color, the position, the font. This separation wasn't just for tidiness. It forced a much cleaner, more maintainable way to build websites. And this is the part that really matters. These new tags aren't just for making the code look pretty. They add real, tangible value. For accessibility, a screen reader now knows, this is the main navigation, letting a user skip right to the good stuff. For search engines, they can pinpoint the main article on a page, which is a huge boost for SEO. And for us, the developers, the code basically documents itself, making it way easier to understand when you come back to it 6 months later.
Okay, the next giant leap was multimedia. For years, if you wanted to play a video or do any kind of complex graphics, you were stuck using a plugin like Flash. HTML5's mission was to kill the plugin and build all that power right into the browser itself.
But before we get to the cool stuff, let's clear something up real quick that trips a lot of people up. Codec versus container. A container, like an MP4 file, is just the box. It's the wrapper. The codec, like H.264, is the clever tech inside that actually compresses the video down to a reasonable size. You need both, and they are not the same thing.
Now, for native video to work, all the browsers had to agree on a standard codec. This kicked off a codec war, mainly between the patent-heavy but super popular H.264 and Google's open-source alternative, WebM. In the end, it wasn't about which was technically superior. It was about pragmatism. H.264 was already everywhere, and as you can see, it wasn't even a contest. It absolutely dominates web video today.
For graphics, HTML5 gave us the canvas element, and it is exactly what it sounds like. A blank, rectangular slate on your page where you can use JavaScript to draw whatever you want, pixel by pixel. It's a low-level, high-performance surface for pure graphical power.
But Canvas isn't the only option. We also have SVG, Scalable Vector Graphics, and choosing between them means understanding a key trade-off. Think of Canvas like a digital photo. It's a grid of pixels. It's blazing fast, perfect for complex, dynamic stuff like video games. SVG, on the other hand, is more like a blueprint. It's a set of instructions for drawing shapes. This means it can scale to any size without losing quality, making it ideal for logos, charts, and crisp user interfaces.
And here's where it gets really interesting. You can take that same canvas element, but pair it with an API called WebGL. What that does is give the canvas a direct pipeline to your computer's graphics card. Suddenly, you've unlocked hardware-accelerated 3D rendering. We're talking complex scenes and games right in the browser with no plugin in sight.
Which brings us to what is arguably the biggest part of the HTML5 story, this explosion of new APIs that finally truly blurred the line between a website and a native application.
One of the first big steps was just giving websites a memory. With local storage, a web app can save data right on your computer, and it'll still be there when you close and reopen your browser. This is the magic behind offline functionality. There's also session storage, which is similar, but it's temporary. The data vanishes the moment you close the tab. Then you get something like WebRTC, which is a total game changer for communication. It lets browsers connect directly to each other, peer-to-peer. So instead of your video call going from you to a central server and then to your friend, it just goes straight from your browser to theirs. That's how services like Google Meet work. It's the core tech that makes real-time video chat on the web actually possible.
And the browser's reach just keeps getting deeper.
The Web Serial API lets a website talk directly with hardware plugged into your USB ports. Just think about that for a second. A web page can ask for permission to connect to your keyboard and update its firmware. At that point, the line between a web app and a desktop utility gets incredibly blurred.
HTML5 also took a shot at fixing one of the web's oldest, biggest problems: passwords. The WebAuthn API lets a website use your device's built-in authenticators, like your fingerprint reader or Face ID, to log you in. It's way more secure because there's no password to steal from a database somewhere.
And then there's the File System API, which is just ridiculously powerful. It lets a web app, with your permission, open, edit, and save files directly on your computer's hard drive, just like a native app. But this is where we hit the messy reality of the web. While the idea is amazing, browser support is still all over the place, which kind of limits how much you can rely on it right now.
All right, let's talk about the final piece of this puzzle: performance. For a long time, the web's biggest weakness was that it was just plain slower than native software. HTML5 introduced technologies specifically designed to close that gap for good.
You know how sometimes a web page will just freeze up while it's thinking really hard? That's the classic problem web workers were built to solve. They let a developer run heavy-duty JavaScript on a separate background thread, so the main user interface stays perfectly smooth and responsive, no matter what calculations are happening behind the scenes.
But the real performance monster is WebAssembly, or WASM for short. For decades, JavaScript was the only language a browser understood. WebAssembly completely changed that. It's like a universal adapter that lets developers take code written in high-performance languages like C++ or Rust and run it directly in the browser at speeds that are shockingly close to native.
And this isn't some far-off theoretical tech. It's powering some of the most demanding web apps you use today. That real-time background blur in Google Meet? WebAssembly. The super-fast database inside Notion? WebAssembly. Discord's advanced noise cancellation? That's WASM too. The entire design tool, Figma, is basically a C++ application that was compiled to run in your browser. Its performance would be impossible without this.
So that's the whole journey. We went from simple documents to full-blown applications that can tap into your hardware, run compiled C++ code, and work when you're not even connected to the internet. Which leaves us with a pretty big question, right? At this point, where exactly does the browser end and the operating system begin?